Hi. Welcome to our class of learning.
Thank you, Harrison McConnell, for that invitation. Okay. Guys, we're talking about linear functions today. Have we done something this year with just the word linear in them?
Yes.
Linear what?
Equations.
Linear equations, okay? Linear functions are the same thing.
Really?
Really.
Wow.
This is going to be pretty simple, okay? But we're gonna add some things to it, okay? All right. Sometimes functions are written using two variables. Which two variables do you think they're going to use?
X and
That's
Y.
why.
X and Y. Okay. One variable, usually the X, represents the, what do we call X? What was it? The domain. Okay. Also, maybe put input. Okay. The X represents your input or your domain, and then the other, usually Y, represents the range or output. Harrison's on fire today. The range or the output. Remember, domain, range, DR, alphabetical order, X, Y. All right. When a function is written in this form, it is an equation. Okay? Now, we're going to represent these things about 5 different ways. You'll see a big, nice little picture on the back to represent all this stuff. But these functions can be represented in words, in a table. How many people realize that this book really likes using tables?
Yay.
Right? Don't we make a lot more tables than we used to?
Yeah.
Yeah, that's the new things that are going on. In a table with a graph. Okay, we graph a lot of stuff. Or as an ordered pair. Some kind of X comma Y. Okay? All right, the graph of a function is the set of ordered pairs consisting of an input. And again, we said our input is our X value. And the corresponding output.
Why?
Which is our Y value. Just some terminology there, people. Write it down. Once we do a couple examples, it'll make sense. All right. What you guys are going to do is make a table of values for the situation below. Now, because we love you guys so much.
Oh, boy.
Oh my god, that's literally
It is literally like.
The table and
It's
the
like a
graph.
food stamp.
So I'm going to give you guys blank ones of these for you guys to do this, okay? So, it makes your life easy. Makes your life a little easier.
yeah.
All right, here we go. All right. Somebody read us the problem about the farmer's market. Do you guys have a farmer's market here?
Yeah.
What
Once
morning?
in a while.
Sunday.
Sunday morning. Where's it at?
Saturday.
Rose.
Was it
Yeah,
Saturday?
Saturday. No,
Or in Mount Prospect, it's always on Sunday morning.
it's like
Rose.
you know where like
Isn't there one of those?
Panino's is.
used
It's
to
by
ride
Taylor.
Flea market.
Where?
It's like it's in the you know where like alright.
It's by
Panino's
Taylor
is.
Coach.
Where's Panino's?
Uptown.
Uptown is by like, I know where the Pickwick is.
Alright, you know like the train tracks?
Yeah.
Like it's like right
Parking
there.
lot there?
I
Go
like
like
trains.
more the other way. Kind of by
Main
towards
Street.
the dealership. Towards
Someone
the,
remind
you
me
know
if I
where?
ever need directions.
It's
my
by
first
the
name.
church. No,
Hey,
I'm
Mr.
really good
P,
at this. Alright,
you know
so you
where
know
the
the train
church-
tracks go towards the dealership, like the
It's by Triangle
Lincoln.
Park.
Northeast, west, or
and
south?
then you go, but like you don't go all the way. You go like halfway, and then you like
Do you know
go to the
where?
park.
Ah!
Do you know where
Got
Zion
it.
on the Run is?
You're really bad at giving.
You know where the Walgreens
I'm
is
really
by
good at it,
Triangle
but-
Park?
Yes.
Yeah,
Just
you
don't
just
know
go a
those
little like this parking lot there. It's right by there.
Got it.
There's like a side.
What do they sell at the farmer's market here?
Fruits,
Stuff.
bread,
Fruit,
Veggies.
veggies.
flowers, and bread.
Popcorn.
Chicken,
Flavors of bread.
honey.
Sometimes decent meat. That's true. Okay.
Cats.
So,
Cats.
the farmer's market sells apples for $2 per pound and oranges for $1 a pound. Marjorie has $10 to spend.
Marjorie.
No more, no less.
I'm not rock at it.
The function, they are going to give you the function sometimes. Y equals 10 minus 2x. Or oranges equals $10 minus $2 for pounds of apples.
Just get 10 oranges.
Okay?
Wait.
Represents the number of apples X and oranges Y Marjorie can purchase. Graph the function and interpret the points graphed. So, guys, we're going to have your table. your first column is always going to be the X or the,
Y.
not the Y,
Input.
the input. You get to input those values, okay? Sometimes they'll tell you what to input. Some, like this one, we're going to be smart and make good decisions. The middle column is always your function. Y equals 10 minus 2x. So I'm going to put that in there. What do you think the third column is going to be labeled? Y, or the
Output.
output. So we're going to input.
The output.
We're going to input some x's, and this is going to output. Okay. Let's see. Remember, x's are pounds of apples. How many pounds of apples could you buy?
Like 5,000.
You only have $10.
One
Yeah,
pound.
You only have $10.
They're taxed.
Okay.
5
There's no
pounds.
tax.
1 pound.
What would be the let's do this in an organized manner. What would be the least amount of apples you could buy?
0.
0. Can you buy negative amount?
No.
No, that's impossible.
Throw
Let's do 0
Well, if
first.
you donate,
We don't have to, but let's smarter do it in an organized way. Now, y will be 10 minus 2 times 0. Plug that in. What's the output when the input is 0?
10.
PB.
10.
10. Somebody explain what that means, those numbers.
So she spent
Two
$0.
times 0 equals 0.
Not spend $10 or $0.
She saved $10.
I have 7. Like,
Say it.
then you get $10.
No. No, because y is the output.
She
You
didn't
bought 0 apples. So
If you buy 0 apples,
She has $10.
keep $10.
No.
She spends 10.
wait, what does y stand for?
The output.
But, okay,
Oranges.
I like
So-
10 oranges.
if you buy 0 pounds of apples,
Buy 10 oranges.
you get 10 pounds of oranges.
Yeah, oranges.
Wait, if you spend $0, you get 10 pounds of it.
But we're going to assume we're going to spend all our money, Nate. We're going to spend all our money. X and Y, guys, stand for
Why don't you
pounds of
say-
apples and oranges, not money. The money is the 10.
I spent a lot of tickets.
Okay. Now, could we buy 1 pound of apples?
Yeah.
Yeah.
Everybody put a 1 in for your X, another input, and put 1 in for X, and figure out what Y is when X is 1.
12.
10 minus 2 times 1.
Oh.
Somebody explain what that means
Oh, yeah.
in real words. Go ahead, Donnie, give it a shot. And 1 pound of apples. Okay? You're going to buy 1 pound of apples and 8 pounds of oranges. Let's do 2 and 3, just to keep it simple. Okay? Y equals 10 minus 2 times 2.
Wait, so like on the test and stuff, everybody can get like totally different answers?
Yes. But when we graph it,
They'll all be the same.
they'll all look the same. When the input is 2, guys, what's the output?
6.
Angie,
6.
6.
Out.
And 3 is 4.
So you could get 6 pounds of oranges and 2 pounds of apples.
4.
3 pounds.
Minus 2 times 2, which is 4. Now, go over to the graph, which is already made for you, and let's graph these points. Okay? Which one is along our horizontal axis?
Apples.
Why?
Because apples is X and X is apples.
Guys, this is our x-axis, and x is our apple, so I'm going to label this apple, label this apples, and oranges goes up the vertical axis.
Oranges.
So, let's do 0, 10, boom! Okay?
I like oranges.
1, 8. Remember, 1 is right in between 0 and 2. So you gotta just, guys, just use your best judgment there. 1, 8 is right there. Okay, 2, 6. Graph that. And 3, 4. Is this linear? Do they line up?
Yeah.
Okay. Guys, wasn't our equation in slope-intercept form?
Should we draw a line?
Yes, good point. Use your straight edges, guys, and draw a line through them. Okay? Did anybody figure out what's the most amount of apples you could buy?
10.
10 pounds.
I don't think so.
5.
Why 5?
Because it's $2 a pound. You have $10.
Oh, yeah.
So I think the other guys, it could have
Why
been
can't you buy 10 pounds of apples?
because you only have $10.
Oh,
and they're $2 a pound. You could have bought 10 pounds of oranges, yes.
Oranges are more
Notice.
expensive
Hey.
than apples in real life, so.
True.
Yeah, we're talking math, we're not talking real life here.
But you said real life.
Don't be weird, Harrison.
Like you said, say it in real life.
Let it go, Harrison.
Alright.
No, it's real life.
So, hey, that was slope-intercept form. The slope is negative. This is written backwards. Y equals mx plus b. They did b, and then the mx over here. B plus mx, so it would be -2 would be your slope, and your y-intercept would be 10. Slope is 10, the y-intercept is 10, the slope is -2.
Aren't you always supposed to use like one negative except for the ones that you can't?
Say again?
Like for this one you can't use a negative, but for one of this just said like y equals like, well, say it wasn't for oranges, like you could do a negative too. Are you supposed to?
Yes.
You have to?
Yes.
Okay.
Which we're going to do in the next page of that.
Ugh.
Okay. Guys, sometimes it's not a real-world situation. It's just a function, y equals -3x. Okay? You guys have graphed a bazillion of these in the last couple weeks. We're going to have you guys do it with a function table now. X, y equals -3x, and we will then get our y after we input some x's. Okay? Angie, question, concern, comment? What are you talking?
Question.
Talk to me.
Like if it's on like a test or quiz, do we have to write a negative in there?
Usually, yes. Yes.
So I can't
Always try a negative one. Here, like what Billy was saying, you could have a negative number. Which, Ange, do you remember which 4 values I kind of encouraged you to choose last time?
0, 1, 2, and -1.
Let's choose inputs, guys, that are nice and easy, and let's choose one negative value. Okay? So everybody figure out what y is when it's with 4 different inputs here. What's y when x is 0?
0.
0. -3 times 0 is still 0. Okay? Some people like to make a 4th column here.
For the answers.
Yeah, let's make an XY column where you just pair them up. So that means it goes through the point 0, 0. What's another name for the point 0, 0?
Origin.
The origin. Guys, this one goes through the origin. Oh, what was B? 0. We already know it goes through the origin. Okay? Try -3 times 1.
It's supposed to look like this.
You got it, pedal cow. -3. So the point 1, -3 is on that line. Okay, try 2. -3 times 2, -6. The point 2 comma -6. Try -1. Uh-oh. Guys, what's a negative times a negative?
Positive.
Okay, +3. -1, +3. All right, graph your 4 points, guys. Always one kid like, can't graph one of the points. It's not on the coordinate system. We know it goes through the origin. 0, 0. 1, -3. 2, -6. Guys, just use your best judgment and get 1 unit off the graph. That's okay. Might happen sometimes. And then -1, +3. Use a straight edge.
Couldn't you just label it so it goes by 2s?
Yeah, that's right.
Ah,
That's what
yeah, I think so. I went by 1s. If you went by 2s, you should have some line that's real similar to that.
Yeah.
Okay. What do we know about that line? What's its slope?
Oh, 3,
0,
3,
0.
3 negative
3,
3 comma
negative
-1.
3,
-3.
negative 3.
Yeah, negative.
Oh yeah, negative.
Guys, the slope is -3. We already know that.
Yay.
Okay. The y-intercept is 0. But we're going to do it with a function table today. All right. All right. Here's the key concept, guys. You can. There's. Everybody jot down on the side over here. 5 ways. And there are your 5 ways right there to represent a function. You can do it in words. You can do it with an equation. You can do it with a table, a set of ordered pairs, or a graph.
I like
I like table.
I like the graph.
I like tables.
Okay.
That was pretty.
As long as they're made.
Hey, watch how this is the same function 5 different ways. The same exact function 5 different ways. The value of y is 1 less than the corresponding value of x. Y equals x minus 1. 1 less than x is y. Okay? Put it in the table. There's some ordered pairs of that info. And there's the graph of that function.
We can use all of them.
They're all the same thing.
You
Okay.
reuse all of them.
All right. All right. Next thing we need to do is talk about continuous and discrete data. This will be brand new to you guys. All right. A linear function is a function in which the graph of the solution forms a straight line. You guys have been doing this for weeks. Therefore, an equation of the form y equals mx plus b is a linear function. What's the name of this form? Y equals mx plus b?
Slope intercept form.
Yeah, it's slope-intercept form. Put that in the long-term memory, guys. Most of you guys have it. Now, you got it. There's some functions are continuous and some are discrete. We got to know the difference between the two. A function is continuous if there's no space in between your data. Continuous means it makes a nice line that does not break or have any space in between it. Discrete data have space in between the possible data values. Discrete means it's like this. You don't connect the dots. Okay? And we'll talk about when things are continuous and when things are discrete.
Wait,
Okay? So, if there's no line connecting your data, that's considered discrete. If it's because like the word continuous, do you guys know what the word continuous means?
keep going.
Look, isn't that continuous? Okay? I guess the word discrete means it jumps and it's not continuous. Harrison,
What if the line is curved? What
that's continuous still. As long as it doesn't stop, Harrison, it's considered continuous. Very good question. All right, let's try a couple examples here. You guys are doing great. Oh, all right, here's examples of continuous. Examples. All right, you guys already know of some continuous ones. A linear equation. A linear equation, guys, is continuous. Okay? Number of pounds of produce. The apples and the oranges example would be considered continuous. Okay? Makes a line. That's continuous. All right. Here's discrete. Space between values. And I think you're going to have to see an example of a discrete example before you maybe really get it. All right, here's a real good example of it. Number of tickets to a movie. How many tickets can you buy for a movie?
How many you want?
Is how many seats are in the theater?
Okay, very good answers. Maybe I'll ask it a different way. How many tickets can you not buy?
0.
Sure, you can buy not. You can buy 0 tickets.
Negative.
numbers.
Negative amount.
Something.
What else?
Oh.
Infinite.
Can you buy 1.5 tickets?
No. Half ticket.
Maybe
Can't buy a half
right?
ticket.
Well, what if it's
Full
like
number.
you have a coupon or you have like a
What if you
child,
decide to
like
share a
an
seat with
infant?
Well, that would just be a cheaper ticket. Would you still have a ticket though?
I guess.
Right.
What if you like just did it?
So, Daisy, the number of tickets are just
Same thing.
1 or 0, 1, 2, 3, 4. There's going to be space. You would not draw a line through that data. Okay? Number of tickets to a movie. How about the? Oh, this is a good one. Number of people in a car. Think about what those values could be.
Can't have a half person.
You can't have a half person in a car.
You can. What if someone chops someone in half?
Well, that would be weird.
What if half
You
of
need more
them
of
is
that.
hanging out the window?
So, but that would not be considered a person, I don't think, anymore.
What if half of them is hanging out the window?
It would be a
It's
corpse.
stub.
It'd be a corpse, right? So, guys, you would not connect the line if we did like
What about
number of
cats?
people in a car, because you can't have negative amounts. You can't have half or a third or a fourth. It just doesn't work. All right. Here we're going to decide. We're going to first write the function, then we're going to complete a function table, and then we're going to say, is this continuous or discrete? Does this make a line, or should we just graph the points and not connect them? All right. Let's say that a store sells nuts for $5.95 per pound.
That's
Yay.
a lot.
What kind?
They're
They're
assorted. Matthew, learn to read. Okay.
That's a lot.
Assorted nuts for $5.95 a pound. Okay. Here we go. The input would be the X, and that'd be the number of pounds you want to buy. The Y would be your output, and that would be the total cost.
Oh.
Okay? See if you can write, use your X, Y, and your $5.95 to write a function rule for this situation. All right, guys, this is a step you guys got to take.
Got one. I got it.
Hello, what do you think?
Y equals 595x.
Perfect.
Yay.
That's what I got.
Go, Matthew. Y equals 5.95x. Does everybody see that? The
Yeah.
total cost will be $5.95 times how many pounds you buy. So let's make. They want us to make a function table for 1, 2, 3, 4, 5 pounds. X, Y equals 5.95 times X, and then our last column is Y. We're gonna need. What are we gonna need here, guys, to do this problem?
Calculator.
Side space,
Calculator.
calculator. You got decimals.
Yes.
Guys, you gotta grab your calculators. 1, 2, 3, 4, 5 pounds. We're gonna do them all. Totally use your calculator here. I can do the first one without a calculator because I know what 1 times any number is.
Really?
The number you started with, $5.95. So 1 pound costs $5.95. Somebody tell me what 2 pounds costs. 11.
$11.90.
Thank you, $11.90. I knew it was 11 something. Okay. 3 pounds will be $5.95 times 3. What's that number?
1785.
$17.85. 4 pounds?
23.80.
23.
23.80.
80.
29.75.
29.75.
Then if we're really hungry for nuts and we need 5 pounds of them,
29.75.
Both of them they cut.
$29.75. Those are some expensive nuts. All right, we're going to graph them now. Okay.
Well,
Notice.
Would you connect?
Was it? Hold that thought.
No.
Hold that thought. Guys, did they make the graph nice and neat for you guys?
yeah.
Remember, pounds goes across the bottom. That's our X, that's our input. And then total cost goes up the side. Total cost goes up that vertical axis. All right, just use your best judgment, guys.
Okay.
Just use your best judgment because it doesn't have the decimal points in there. So 1 pound is $5.95. Such 1 is right above the 5. 1 just above the 5. 2, $11.90. A little bit higher than the 10. Has everybody seen how I'm doing that? Ooh, what if you buy 0 pounds of nuts?
It'd be on the origin.
Well, how much would it cost?
$0.
What number means nothing?
0.
So the origin is part of this graph. Okay, 3, 1785. That would be a little bit above halfway between 15 and 20. Think about it. Ooh, does it look linear to you guys? Of
Yes.
course it's linear. Guess what the slope is?
5.95.
4, 2380. A little bit closer to the 25. And then 5 to 2975, which would be right below that 30. 2975. All right, here's my question. When you go to the store,
Yes.
imagine a big barrel of nuts.
That's a lot of nuts.
Oh, I've seen one of
Okay.
those before.
And you're going to buy some. You got that big silver scoop. You're pouring them into a bag.
Bag
Can
nuts.
you buy a half a pound of nuts?
Yeah.
Yes.
Yes.
So
Billy, my question to you: do we connect these?
No.
No, you're wrong.
Right?
Yes, we do.
Yes.
Because the point, hey, because the points in between count. You can buy a half, a third, a fourth, a fifth. You can buy a fractional part of a pound of nuts. So, Billy, my next question to you. Please make me look good. Is this continuous or discrete?
Yeah.
continuous.
Continuous is a straight line.
Does it make
Yeah.
guys?
No holes.
This one is continuous. This one is continuous. All right, last problem, guys. I know it's been a long.
Did we have to do this last time?
This one might not be continuous. Hint, hint. Okay. All right. Anybody out there who has satellite cable, like DirecTV or what's the other one? We have DirecTV.
I have direct
Is that satellite?
I have
Cable.
Wow
I have
TV.
direct TV.
You have WoW?
Wow.
We had WoW for a long time. We just got rid of WoW.
What is that?
Harrison making duck sounds.
Wow, I love Wi-Fi.
Where do you find that?
No, WoW. Hey, Harrison, what does WoW stand for?
Wireless.
Wireless.
Wide Open West.
Really?
We had WoW forever. We just got rid of it like a year ago and got DirecTV.
About
I
a
have
year.
to-
Are you
about a
happy
year
with your
ago.
choice?
Yeah, we like DirecTV. Good. All right.
Dish doesn't have
I just don't have argument.
Wow
Yeah.
sucks.
We got it because WoW didn't have the NFL network. That's why we got rid of it.
No, it's,
I couldn't take it
has
without the
now.
NFL network.
It
All
has
right.
now.
Satellite cable company charges an installation fee of $50 plus an additional $35.95 per month for service. So you got to pay $50 for them to come out and install all the dish and all the stuff they need to install, and then it's $35.95 per month for service. Write a function to represent the total cost of any number of months of service. So everybody jot this down at the top. X equals months. That's our input. And what does Y stand for?
Total cost.
The total cost. Can anybody write the function rule for this cable company?
Y equals.
35.95x
Plus 50.
Y equals, very good, Colin. The total cost will be $35.95 times the months plus a constant of $50, because that's how much it costs for them to come out and install whatever they need to install. There's your function rule. Okay, let's make a table to find the total cost for up to 5 months. So, Y equals 35.95 X plus 50. I need a wider column there. There's Y, and we're going to do this for 1, 2, 3.
50 for 1 month.
No, you only have to pay 50 one time.
Yeah.
Ah, what if you don't? 0 months. Day 1, they come out and install it.
$50.
You got to pay $50 for 0 months. Okay. All right, let's try for 1.
So what if you not add
$35.95 times 1 plus 50. Say your question, Ange.
What did you not add 50 to each month?
Not each month, you would, just one time.
75.95.
So you want to add it to 2, 3,
Well, what you're going to do in the next one is put 2 in for X. So it'd be, well, you'll see when we do 2, watch what we do. Anybody get this one yet?
I did.
What is it?
75.95.
I think it's 85.
Oh yeah.
85.95. So 1 month of service, guys, costs almost $90. 85.95.
That
That's
sucks.
a lot.
That's a lot for one service, for 1 month. $35.95 times 2 plus 50.
Minus 50.
No, plus 50.
You said times.
No, she didn't.
I think I said plus. We can rewind the tape.
Yeah.
Review the tape, please. Okay, somebody go 35.95 times 2 plus 50. Come on, guys. Every practice, type it into your calculator. How much? 121.90. So 2 months is $121.90. Do it for 3. 35.95 times 3 plus 50.
That would be $169.85.
159.85.
Okay. So.
4. Do it for 4.
169 or 159?
Is it 159 or 169?
169.
It's 69.
Somebody verify that.
Verified.
169.85?
Yeah.
All right, do it for 4 months.
280 point.
No, it's
No way.
209.80.
209.80.
Oh, we don't even get price on here.
249.
Okay. 5 months. And again, guys, this is the total cost. This is not per month cost. I need to make
249.75.
0.75. Okay.
Why does it always go down
All right.
to 5 cents?
Make a table. Make a function table, guys, to show the cost. Oh, we did that already. Graph that function. Okay? Now, here's my question. Does this one go through the origin? No.
No.
It actually starts at 50. So 0.50, guys, it starts at 50. Because you can never not pay any money in this situation. Now, again, just use your
It's
best
not
judgment.
MTV.
Yeah, if you just not get it.
Yeah, if you just not get it, I can agree with that, but we're saying we got to do something for this function. 1 at 85. 85 would be a little bit below a hundo. Oh, let's label our axes. Our x-axis is months, and our y-axis is the total cost.
I said months.
Okay? 2, 121. A little bit below halfway. 3, 169. That'd be a little bit, the closer to 200 or closer to 150?
150.
Closer to 150. 4 would be over 209, just a little over 200. And 5 would be at 249, which would be just below the 250. It's linear.
Straight line.
Right? All right, now, hold on. Is this continuous or discrete?
Discrete.
You would not connect this one. This one is discrete, okay? Because you can't have half months. You're either going to pay for the month or you're not. So this one, guys, do not connect with the line because it's discrete. Okay? You're probably going to have some of those. Interpret the points graphed. You know, that'd be, at 0 months, it's $50. At 1 month, it's $85.95. And then they're saying, talk about what the points mean. That's what it means by interpret the points graph. All right. Any questions, guys, on what you're doing? Is this anything different than we've done in the past? No. It's just in tables and graphs. Very funny.